Welcome to Maths and Science by IITian channel. Today, I want to take up a challenging question for JEE Advanced and also for JEE Mains. I have given a homework for you in the last lecture where we have calculated minus infinity to plus infinity 1 by 1 plus x to the power of 4 dx using the residue theorem. Using the other procedures also we can find, but with residue theorem we are able to solve it in minutes, in 1 or 2 minutes. Similarly, this particular problem I have given you as a homework. How many of you have done it? I am not aware, but it's a challenging problem. Hence I thought, let me take up this problem and solve it for the benefit of all who are listening to my or viewing my lecture from my channel Maths and Science by IITian. The question is, find the integral 0 to infinity cos ax by bx square plus c. Everything arbitrarily I have taken by my intuition. Dx is equal to how much? This is the integral we have to solve, where I have given you in the last lecture as a homework. It's a challenging problem. It takes little 2 or 3 minutes for residue theorem to solve from the residue theorem, but when you go for the alternate procedures, it will take a lot of time. To save the time in examination, we require tricks and shortcuts, and also not only shortcuts, or also alternate methods where we can quickly solve the problem. Hence, here we practice applying the residue theorem so that it will become handy for you in the examination whenever this type of tough improper integrals occur in your JEE Advanced or JEE Mains examination. Now, we will try to solve this question. I will go little bit fast in this because I have already given enough of introduction regarding residue theorem in the last lecture and also previous to that last lecture. Hence, bear with me, I will go little bit fast. The given integral I is equal to integral 0 to infinity cos ax by bx square plus c. Just check up if it is so. Yes. Now, in this, what is the value of cos ax? Cos ax is equal to e to the power of iax, if I am not wrong. Cos ax is equal to e to the power of iax minus I into sin ax. If I consider only the real value, then cos ax is the real value. This is the real, this is the imaginary, this is the value e to the power of iax. Now, if I take the real value, then I becomes the integral value I is equal to real of 0 to infinity. Whenever you take only the real values, you can neglect the imaginary value. So that real value of 0 to infinity, cos ax, what we are replacing with? E to the power of iax by bx square plus c when we are doing the integration of the only real part of the imaginary complex number, only real part of the complex number. Then cos ax by bx square plus c dx becomes e to the power of iax by bx square plus c 0 to infinity. Because cos ax is even, that means even means what? Cos minus ax is equal to cos ax. Hence, it is even. Sin minus ax is equal to minus sin ax. Hence, it is odd. That is the difference between even and odd. Because it is an even, the integrand is an even. From the definitions of the integrals, from the basics of the integrals, we can change the limit of the integral. Instead of 0 to infinity, you make it minus infinity to infinity. Then I is equal to 1 by 2 Re minus infinity to plus infinity. Because in residue theorem, we are required to convert the given integral to minus infinity to plus infinity. Given integral is 0 to infinity. To convert it to minus infinity to plus infinity, we have to divide it by 2 because it is even. E to the power of iax by bx square plus c. I think this much you are aware because you have already studied integrals in your what you call 12th class HSC, and you are aware of little bit of integrals and their definitions and properties, which I am not going into because I told you I want to go fast. I want you to make and appreciate the importance of residue theorem and application of residue theorem. Now, the final integral is this one, which we have to evaluate. Now, instead of x, let us replace it by z. Replace x by z. Then it implies function z is equal to e to the power of iaz by bz square plus c. This is what is required in the residue theorem. And we have to find out when denominator becomes 0. To find singularities, we have to find the singularities. To find the residue, singularities, denominator is equal to 0. That implies bz square plus c is equal to 0. That means z is equal to plus or minus square root of c by b. This much you are aware. And apply the semicircle rule. Apply semicircle rule. Because as limit extends to z extends to infinity, limit z tends to infinity, 1 by bz square plus c tends to 0. Hence, we can safely apply semicircle rule. For the explanation of semicircle rule, please refer to my earlier lecture. Now, we are able to apply we are fit to apply the semicircle rule. From the semicircle rule, what is the rule it is? We can find the residues As per the semicircle rule, we can find the residues and we have to find the point of singularity which is applicable. As per semicircle rule, we have to find the point of singularity which is applicable to us. This is the semicircle, only upper half we have to take. In the upper half, z is equal to plus or minus square root of c by b. Here I is there, because it is bz square is equal to minus c, that is equal to plus or minus I into square root of c by b. Now, residue is at minus I, z is equal to plus I into square root of c by b, singularity, z is equal to minus I into square root of c by b. Only positive values of upper half we are taking because semicircle rule is applied. We will be taking only residue is required at singularity, z is equal to plus I into square root of c by b only. Then, as per the residue formula, what is the residue formula? Residue at z is equal to square root of I into square root of c by b, that is equal to, what is the residue definition? Limit, either you do the differentiation phi x by psi dash x, or you take the limit. Differentiation and limit doesn't make any difference. Z tends to, where z is required, limit of z where I into square root of c by b e to the power of I a z by b into z minus I into square root of c by b, z plus I into square root of c by b into, because we are dividing and multiplying with z minus I into square root of c by b, so that you will get a reasonable answer. Because what it is, the function is e to the power of I a z by bz square plus c. We have just changed and rearrangement we have done to find out the limit. Nothing in this, nothing to worry. Then this residue becomes e to the power of minus a square root of c by b divided by 2i into square root of bc, residue. These values, these finding limits, differentiation, these steps you please see, and I don't want to waste time for solving this what you call small things like sorts, a minus ib into a plus ib is equal to a square plus b square, those things you please take care. Then by applying the residue theorem, what is the residue theorem says? Residue theorem is integral is equal to function z dz is equal to 2 pi I into residue. The main crux of the problem in the residue theorem is which residue to apply. Once you correctly find out which residue to be applied, then you can just simply find out the limit of it, applying the equation, get the limit of it, or psi x by, I told you already, phi x by psi dash x. In the previous lecture I have clearly told you, please refer to my previous lecture for these steps. Previous lecture, please refer to previous lecture. Once you see the previous lecture, you can very well understand the easily understand the procedure what I have followed. Now answer is equal to integral fz dz is equal to 2 pi I into what is the residue? E to the power of minus a square root of c by b. These are all small things. You please take care. Division, multiplication and other things. And it comes to pi into e to the power of minus a to the power c by b divided by square root of bc. This is the residue. Because this is for minus infinity to plus infinity, for which we have calculated. But what is required? 0 to infinity. Hence it should be half of it. Hence the value I is equal to integral 0 to infinity cos ax by bx square plus c dx is equal to half into pi e to the power of minus a c by square root of c by b by square root of bc. For example, if I wanted to find out, this is the answer. It's a challenging problem. It requires little steps which you are supposed to know, and if you are fast in your calculations like limits and also surds, you can easily do it very fast. It is not a big problem, it is a big problem, but still you can do it in a minute or 2 minutes time. Even though it is of IIT Advanced or JEE Advanced or JEE Mains level, you can easily do it. Provided you should be able to do the surds, you should be thorough in your surds, limits and finding residue. Before that, you should know how to find which point to be considered for calculating residue. Now, as a limiting case, let us say b is equal to c is equal to 1. What happens? This becomes I is equal to integral 0 to infinity cos ax by x square plus 1. This appears in many examinations. It's a standard integral. It appears in many examinations, and this value is very important. And the original, I converted this to bx square plus c and found out. And if you put b is equal to c is equal to 1, then this reduces to standard integral pi by 2 e to the power of minus a. Yet higher level examinations like JEE Advanced, JEE Mains, CSIR exams, you will get this type of questions, and you should know that integral 0 to infinity cos ax by 1 plus x square, it can be a part of your problem, is equal to pi by 2 into e to the power of minus a. This cannot be that easily solved by other alternate methods. It is better to go for residue method. If you can remember this value. Otherwise, you can get this value in minutes, in a minute or two, by applying the residue theorem. And I want to give, or I want to take one or two more examples on residue theorem application so that you will appreciate it. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. And I am from Maths and Science by IITian. And if you feel my lectures have added some knowledge to you, or value addition is done to your knowledge, please share and subscribe to my channel. Thank you. Best of luck.